I'll give you a brief introduction to Econolyst, the company I run, explain a bit about what we do, who we work with, and why we do it. Talk about this conundrum of 3D printing, additive manufacturing. I want to talk a bit about ecosystems. It's a wonderfully overused word in industry at the moment. It's something of a grotesque buzzword. I want to talk about the whole additive manufacturing and 3D printing ecosystem, whether we really live in one. And then I want to talk about something called blue water. If any of you are not familiar with the concept of blue water or blue ocean theory, it's a business methodology that says, stop building maker bots, everybody, they've already done it. It's about coming up with new ideas, new innovations, not competing in the primordial soup of dirty red water with shark teeth everywhere. It's about coming up with new things. And then I want to give you some ideas of where we think things are developing, how things might change over the next 10 years, and how it might blow some holes in some of our projections about market size and scale and opportunity. So it's a pretty generalist catch-all presentation. So Econolyst, our little band of clever folk. We're a 3D printing additive manufacturing consultancy. We have a few machines, we have a few toys and bits of technology, but most of what we do is strategic. It's looking at the industry, it's looking at how companies embed technology. We've been doing it for a long time. We've been around for about 11 years. I've been doing this for about 20 years, so we've seen things come, we've seen things go. We've got excited, we've got demoralized, we've got very excited, we've got very demoralized, and now I think we're quite excited again. Econolyst is an interesting bunch of individuals at the moment. We're not all engineers. We have some social scientists, we have economists, mathematicians. We've got a retail and HR expert, and HR is really interesting. So recently we've been looking at what happens when you put these technologies into the high street, in the shopping mall. What does it do to people? How does it change the working life of somebody who thought that they were, brackets, a shop assistant, when all of a sudden they become a manufacturing engineer? How do the unions take to that? How does that change employment contracts, working conditions, environmental health and safety? So some really quite interesting things. So those are the types of people that we have. Unfortunately, sad indictment of UK manufacturing, 85% of our revenue is not in the UK. A very large percentage of our client base is in North America, the Middle East and the Far East, and Scandinavia, but that's just because we like skiing and good fish. So what do we do? I guess about 60% of our revenue comes from what we call end-use work, working with clients who are trying to embed these technologies into their business, into their value chain, whether they're retail companies, defense companies, healthcare companies, telecommunications companies who are looking at data, whether they're logistics and distribution companies who move objects. Additive manufacturing and 3D printing cuts across all of them, and it impacts all of them. We do a lot of work with vendors, hardware, software, materials, and a bit with the investment guys that make the oil that makes the wheels flow. Just to give you an example, because it kind of leads into some of our thinking. So a lot of our experiences are based on some of our client work. So something we did a couple of years ago was working with IBM, who came to us and said, in 10 years' time, we're going to live in a totally different world. Factories will be completely different. And we went, oh, you've heard all this before, 3D printing. And they went, oh, no, forget 3D printing. What about open source electronics, open source hardware, Arduinos, Raspberry Pis? What about accessible robotics? Baxter robots, $20,000, cheaper than one person's annual salary, easily programmable. So what happens when you meld that with 3D printing and all of a sudden you have literally a factory in a box where you can compete using open source hardware and software against Bosch and Samsung and Apple and whoever? Is that true? Is that going to happen? So those are the sorts of things we get involved in. We did some great work with our friends at BMW last year where their senior management postulated the idea that every design engineer should have a low-cost 3D printer on their desk. And we postulated the idea back to them that that would lose them a significant amount of money, and that actually that would be counterproductive to innovation. So those are the sorts of things that we prove. We've had some interesting work with our friends at Boots, looking at the retail conundrum. What would happen if you put a 3D printer into 2,000 retail outlets? What would you make? Well, there's lots of things that are already being made that cross over into healthcare. Hearing aids, orthotic insoles, glasses, rehabilitation splints. Okay, they're all markets, they're all scalable and sizable, but is there a back-end supply chain that could feed that? And could you implement that on the high street? We've got some interesting stuff being published at the end of this month with the Intellectual Property Office, just to watch out for, which is the first government-funded study on the true IP implications of 3D printing. So what happens when people actually start genuinely counterfeiting files? What happens when people modify a counterfeited file? What happens when you go and have your selfie scan and then you discover yourself as an intellectual property being made by someone you didn't agree to make it? So lots and lots of weird and wonderful IP considerations. And we've done some nice stuff with Adobe recently, looking at the whole integration of software tools into consumer 3DP. So that gives you an idea of our working world and the things that we get involved in. So 3D printing, is it the same as additive manufacturing? They get used interchangeably, and quite often nobody seems to justify why. Within our company, we have a very, very defined set of rules. We think they're completely different. They're totally different. Our clients who are interested in 3D printing, in many cases, are not interested in additive manufacturing and vice versa. So to us, 3D printing is associated with people. It's associated with manufacturing in the home. It's associated with manufacturing in the community. It's where the ultimate end customer is also the manufacturer. Now, you can decry that as being childish and nonsensical, and 4 years ago, the 3D printing community didn't exist. The additive manufacturing community was on its high horse, saying this is all childish and nonsensical. And now actually 3D printing is an industry in its own right, with value chains and materials and machines and data, software tools, infrastructure. To us, additive manufacturing is actually associating the layer-based manufacturing concept with a traditional supply chain. So it's companies who, in many cases, already exist. They already have a supply chain and a value chain, and they're displacing the way that they do something using an additive approach. That's very different to 3D printing. You know, you do not 3D print cruise missiles, you additively manufacture component parts for cruise missiles. They're two very different things. What, of course, they do share is that they both make things in layers, and you could therefore say that, yes, they share a common ecosystem. I said I'd explain a little bit about ecosystems, because this is important to this presentation. It's an overused term. It's an overused word, ecosystem. If you actually look at it, the definition is it's a community of plants, animals, and smaller organisms that live, feed, reproduce, interact in the same geographic area or environment. So for the benefit of Graham Tromans, that's Birmingham. Is that right? No. So that's an ecosystem in biological terms. In business terms, a business ecosystem is a network of organizations, suppliers, distributors, customers, competitors involved in the specific delivery of a service through both competition and collaboration. And specific is the important word here. Where is the specific here? Well, the specific is the additive, doing things additively. Because the software tools you need, the materials you need, the machines that you need, the business benefits that you gain, all come from the additive element. The ecosystem is the additive element. The other thing I said we'd briefly touch on before we start is this idea about red ocean and blue ocean strategies. So simply put, the difference here is the blue ocean strategy is that you go out looking for something new. You don't do lots and lots of market analysis about how big is the market, because the market doesn't exist. That's kind of part of your red ocean strategy. Your red ocean strategy is, oh my goodness gracious me, Brie Pettis sold MakerBot for 600 million. I better start making hot snot dribblers as well, because somebody will come and buy one from me. That's red ocean strategy, following the things that have been competitive. So what I want to do is kind of touch on where the red oceans are and try and see where the blue ocean still remains within additive manufacturing and 3D printing. Does it constitute an ecosystem? Is there any blue water? So that exposes really the title for the presentation. So simply put, we think the ecosystem kind of splits up into these two domains. So you've got manufacturers, retailers, and brands. And down here, you've got companies that make absolutely everything, and consumers who make nothing and consume everything. And at the other end, brands that make nothing and consumers who make everything. So that's where the Economist assumes we're all going to get to. And at the moment, we actually sit somewhere in between here. So that's the basic framework of this ecosystem. But of course, around it, you've got some commonality. You've got materials that, in some cases, consumers use, like ABS, but it's also used by industry. You've got software tools that it's progressively becoming difficult to delineate. Is it industrial? Is it consumer? Is Adobe now a consumer tool, or is it an industrial tool? Or are the Autodesk suite of products that Jordan spoke about earlier, are they within the consumer domain or the professional domain? So actually it all kind of wraps around. And then you've got hardware, and that's getting really interesting, and I'll talk about that later, where we're seeing convergence of consumer and industrial technologies. So actually, it is, in that respect, an ecosystem that the consumers, the manufacturers, the hardware, the software, the materials, all feed off one another. There's a bit of glue in the middle, which is quite interesting, and that's the use phase. So down here, yes, you've got companies who are making things they vend to consumers. You've also got service bureaus sitting in the middle, you've got local hubs, and up here, of course, you've got home users. So it kind of gets a richer ecosystem. So let's talk about opportunity in all of this. So we'll kind of start from the outside of the diagram. So the technology, those rings around the outside, hardware, software, materials. If you look at this, it's becoming an ever more populated map of technology. So according to the US ASTM F42 committee, there are 7 types of additive manufacturing. There are 7 ways you can make things additively. I'd love somebody to come up with an 8th, because nobody has for probably 15 years. So we can make things by powder fusion, directed energy deposition, material jetting, binder jetting, material extrusion, vat polymerization, sheet lamination. Some of these are easier to do than others. Sheet lamination is not particularly difficult. Vat photopolymerization is getting easier. Material extrusion is exceptionally easy. Binder jetting is really quite easy, but it's still covered by IP. Directed energy deposition is not very easy. Powder fusion is not very easy. And you start to see some interesting numbers. The things that have fallen out of patent and the things that are relatively easy to do, like material extrusion polymers, there are 260 low-end additive manufacturing vendors in the world now. Yeah? What we're now starting to see is vat polymerization, which has come out of IP. That's starting to grow. There's now 8 of those. The interesting one at the moment, powder bed fusion, lots of metals. Polymers is starting to grow. We've started to see the first Kickstarter campaigns for laser sintering machines, $5,000 laser sintering machines, $20,000 laser sintering machines. So again, looking at this from a red water and a blue water strategy, is this really the domain you want to be in, making more and more and more ABS and PLA extrusion systems, or is there somewhere else in here that's actually a fruitful domain to be? If you look at the majority of additively manufactured parts in the world, they're made on 2 technologies. Selective laser sintering in nylon and the 3D Systems Project 660 Forma Z-Core type color plaster technology. That's where the mainstay of parts are made. And actually, oh, that's interesting, because that's where we're starting to see some growth. But there's still certainly some blue water in those domains. If you look at software, this is an interesting thing. You look at software in our industry, actually you have to have quite a broad portfolio of software. You know, we need to have software that takes scan data from photogrammetry or point cloud or whatever the scan source is, crunches it through some CAD graphical modeling, gives you the ability to modify shapes, change shapes. You've got to get it into a printable form. Maybe you want to link it into a printing service. And if you map most of these things out, there are very few pieces of software that actually sit in all of the different domains. So, you know, if you look at this, it's interesting. There's not many STL and mesh processing software tools available. There's quite a lot of CAD and graphical software, particularly at the very low capability end. More and more and more of it. And more of it's going to the cloud, HTML5 based cloud software in the cloud services. As we get up here, there's less and less tools available to us. Is there opportunity in the software domain? Probably. How you monetize it is the difficult one. Materials, the materials landscape. If you've ever seen the Polymers Handbook or the Granta Polymers DVDs that you can buy, there's what, 40,000 engineering polymers in the Polymers Handbook? And we still have a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So not really an extensive list of polymers that we can work with. We're seeing more and more emerge all the time. We're seeing lots of new polymers companies launching materials for both FDM and for powder bed systems. Metals, we actually cover quite a lot of bases in metals. Ceramics is grossly underrepresented. There's a huge opportunity space for engineering functional, high temperature, stable ceramics, but it's not an area that people have been doing a lot of development on. I think I heard Jordan mention this earlier, tissues and cell and all the nasty, horrible stuff you don't really want to talk about. I'm sure there's lots of opportunity up there if you're a biologist. Everyone I ever talk to about 3D printing and biology says, why do 3D printing people keep talking about 3D printing cells and scaffolds and 3D printing ears and noses? And it's nothing to do with 3D printing. It's 1% 3D printing, 99% biology. The 3D printing is just the enabler that gets the clever biology to work. So if there's any clever biologists in the room, there's probably some opportunity space. If you're just an engineer, I wouldn't bother thinking about the tissue engineering stuff. It's a bit too clever for us guys. Okay, how about services across the supply chain? That bit in the middle. We're seeing so many more companies popping up in this domain in the middle, offering the service of linking manufacturing requirements to consumer demand. At the bottom end, you've got companies doing it themselves, and you know, teaching grandmother to suck eggs in this room, but there's lots of reasons why companies are doing this. You know, why do you make a transition to additive manufacturing? Why is there a business benefit? You know, we think if you break it down, there's some pretty obvious ones. You know, less tooling makes cheaper components if you're making low volume components. That's excellent for product personalization. You know, increased geometric complexity, that's also great for product personalization. Faster to market, shorter supply chains, all the usual stuff. Interesting stuff though, new retail models, new market models. That's where we're seeing more growth in additive manufacturing and 3D printing. We're seeing more opportunities emerging in the softer side of engineering than we certainly are on the harder side. There's far more happening in terms of high street opportunities, retail opportunities, than there are trying to stuff this into aerospace. So we've been doing that for 20 years. Parts with better functionality, I'll talk a bit about that later, and geometric freedom. That's why companies love this stuff, because it enables new business models, it enables new things to happen. So that's kind of where the opportunity is to a business. If you think you're just going to use additive manufacturing to replace injection molding or replace CNC machining because you think it might be cheaper, then you're probably wrong. What you need to do is find a compelling business case that exploits some of these benefits. That's when you find a use of the technology. So we've, I'm sure, seen most of these before. Examples of what's happening in the additive manufacturing world. It's crossing just about every domain, from manufacturing low volume drones through to manufacturing cars that you really wouldn't want to drive around in, to manufacturing cars you would want to drive around in. So it's a bit of an arty-farty photo, but that's the exhaust pipe off a Koenigsegg 1. Hands up in the audience, who's got a Koenigsegg 1? No, because they're £1.5 million and they only make 6 a year. But what's really nice is if you open the bonnet on one, you'll see the turbocharger's made out of selective laser melted titanium. The exhaust pipe is selective laser melted titanium. There are 32 FDM component parts dotted around the car. Why? Well, because it makes economic sense when you only make 6 a year and sell them for £1.5 million. Doesn't make sense if you're General Motors and you're making 400,000 units a year. Local Motors with the car they made last week or the week before, out of an FDM carbon-loaded material. We're over in the construction domain now. We've got construction scale objects being made, modular housing, the ubiquitous GE jet engine fuel nozzle. Really interesting part, this. You know, this has made people's stock price valuations go through the roof. GE are going to start making aeroplanes using additive manufacturing. No, GE are going to start making one component part out of an engine using additive manufacturing. Why? Well, think about the business benefits, think about that component part. It's non-dynamic, non-structurally loaded, very, very low in terms of its thermal loading, and there's 19 of them in each jet engine. Oh, and by the way, the other thing, that is the value add of the LEAP jet engine, is the fuel efficiency that comes from the design of the nozzle. So that's the thing that allows GE to sell it for a premium. So all of a sudden it becomes economically advantageous to have an additively manufactured fuel nozzle for a jet engine. It costs orders of magnitude more than machining it or casting it, but the geometric benefits make it valuable when you sell it. Lots of dental, lots of high fashion and couture, lots of implants, lots and lots of homeware. This is additive manufacturing. This is established supply chains. These things exist. Aerospace, construction, homeware, medical, footwear. Drones kind of exists. Automotive, they all exist. They're all existing supply chains that are embedding additive because of the business benefits that you get. So this glue in the middle, that's companies doing it for themselves. You don't have to do it for yourself. There's a lot of opportunity in what we historically have called the service bureau market. And there's lots of service bureaus outside offering the service of being the intermediary, sitting between the design, the innovation, the engineering, and the ultimate user of the component parts. What we've also started to see recently is what we've kind of called local and virtual hubs. So, the internet's a wonderful thing. All of a sudden, as long as you can write code, you can write an internet concept where you can link together capacity. So Shapeways is a good example of this. Sculptio is a good example of this. Craftwork is another example. Pinoco is another example. Organizations that don't necessarily have all the capacity, they go and buy capacity, broker it, bring it together, and sell it to you as an end user. The one that I absolutely love, and I think these guys are outside, is 3D hubs. I'll come on to 3D hubs later. This is a kind of crossover. So as you can see, we're going up my domain more towards the home rather than the industry. 3D hubs is a network of, I think at the moment, 5,700 3D printers around the world, all plugged into one common internet platform. That makes it the biggest network of 3D printers anywhere on the planet. And what's really neat about 3D hubs, when they launched, was it was for consumers with consumer printers who wanted to make their printer available to the guy next door. And what's happened is they've had hundreds of service bureaus plug onto the ends of the nodes of 3D hubs. So actually, it's a fantastic place to go to get parts. But it's more towards the consumer domain. And then, of course, we've kind of got the home printing. So let's kind of talk about the other bit of this ecosystem, the exciting bit. So how are people linking all of this together? Where are the business opportunities? You've got the manufacturers, the brands, the retailers, you've got the consumers, you've got the hardware, the software, everything around the outside. And what we've got are these really interesting things starting to emerge. So at the bottom end, things where manufacturers make nothing, consumers make everything, and you don't even monetize it, is your online data repositories. So these are people like, I suppose, Shapeways is probably MakerBot is probably the best example with Thingiverse. Huge repository of printable, questionable content. Yes, it's printable. Do you want it? Do you not want it? It really doesn't matter. It's there. You can have it. How you monetize it, there are ways to monetize it. We've seen lots and lots of different business models emerging. Monetizing it is about selling data. We did some analysis last year for one of our clients, and we canvassed the views of 3,500 people who owned consumer 3D printers, and 8% said they would ever pay for data. We live in a world of free downloads, or we live in a world where data, you'll only pay for it if it's highly accessible and highly valuable, i.e. the iTunes model. But there are ways of monetizing data. So online data repositories. The best one I've seen recently, I don't know if anyone knows Chris Thorpe. This guy has a brilliant business called I Can Make. And Chris's background's in education and software and gaming. And he kind of said, well, there's a real drive to get 3D printers into schools. They're amazing. Kids should all know about 3D printing. No, they should all know about manufacturing and science and traditional processes, and they should know about computing and everything else. So what Chris did was he said, actually, the way that you stimulate kids to be interested is, yeah, you get some low-end consumer 3D printers into schools, but then you give them useful content that actually is the education. The 3D printer is not the education. That's about 15 minutes worth of educational value, where you can talk about molding materials, X, Y, Z, control systems, possibly design. So what Chris has done is he's gone around the world and found 8 iconic objects and then got licenses for those iconic objects. So what you probably can't see, or you might just be able to see, is the beginnings of Tower Bridge. So Chris has teamed up with the City of London Corporation and has licensed Tower Bridge. So they gave him the original drawings. There you go, 200-odd-year-old drawings. CAD them up. So they CAD'd them up, and they made it available to schools as a download, which they pay for. But that's not it. That's not enough. That's dull. That's boring. What they also do is sell you the entire kit to mechanize it. What they also do is sell you the kit to turn that into an Internet of Things device. Because you might not know it, but Tower Bridge tweets. They're probably one of the most boring Twitter feeds in the world, but every time it opens, it tweets. And that's 5 times a day on average. That's pretty dull if you're just reading Twitter. It's really exciting if you're in a classroom and you're building Tower Bridge. And when you've finished it, it starts opening and closing through the day every time Tower Bridge opens. Oh, and there's a webcam on Tower Bridge as well, so you can go and have a look at what's going up and down. So that's about adding value. So all of a sudden, selling data isn't just about selling printable data. It's about selling value. That's where the opportunity space is. It's about understanding that market. Online design tools. another area, moving along the domain here. So this isn't all about consumers making things themselves or making things in the community. This is about consumers engaging in the design process of the products they buy from manufacturers. That's a different concept. If you look at the traditional value chain of product innovation, you've got at one end, your marketing guys go and do some market research and market innovation work, sit down with some focus groups, come up with a product concept, your concept design engineers get hold of it, then your product design engineers get it, and then your production engineers get it, and then your manufacturing engineers get it, and then your sales guys get it, and then your retail people get it, and then consumers get it. And that's a hell of a long way divorced from the start of the process. So why not re-engineer the process so the consumer is the front, the consumer is the designer? Because bear in mind, what did I say about the business benefits? Low volume, singular unit volume, no tooling. All of a sudden you can make individualized products for consumers. Like it or not, and I love the company, I hate the product, this is a great example, Makey Labs. So Makey Labs have been around now for 4 or 5 years, I guess. Targeted on a very, very niche element of the toy industry. So not necessarily for kids, more for early teens, late teens, early 20s. And it's a community product. So anyone who's not familiar with Makey Labs, what you have here is a series of figures, dolls. They are approved as toys, so they have CE marking approval as toys. They're laser sintered. They're additively manufactured, the faces and the bodies. But you design them yourself using really simple tools. You just go on your iPad, on your iPhone, load of sliders, you configure it to you, then you hit print, and their back-end fulfillment system feeds that into a series of manufacturers and it's shipped to you. And that's becoming a really, really common business model that we're seeing emerge. That in itself, certainly not the Makeys wrote their own code, but if you don't want to write your own code, there are companies like Digital Forming who actually have software tools you can embed in your website as a brand to allow your customers to modify their own product. So with Digital Forming, what you do is you embed that in your web offering, into your web shop or web catalog or whatever, and you get your engineers to put your products into it and define the constraints, define the parameters. So if you're making glasses, you don't want the arms to be too thin or the lenses to be too big. So your engineers define that, and then they set the boundaries the consumer can change. So the consumer gets the personalized product, and it feeds into that very different supply chain model. Of course, the other benefit is you're making to order, not making to stock. In most cases, it's cash positive. They take credit card payment for that long before it ever exists as an object. So again, that's a very nice business model to have. Moving further down, we get some quite interesting things where the consumer isn't even engaging in the design of the object. The consumer is the object. This is your mini-me's and your avatars, and this is incredible. This is really growing off the back of this obsession with selfies. I'm certainly not obsessed by selfies because I really do not want to look at me. I'm looking the best way, trust me. Kids are obsessed by selfies. Young people are obsessed by selfies. Young people are now becoming self-obsessed with 3D selfies. And it's getting easier and easier and easier to extract 3D geometry and color reference data from people. So that's growing a whole kind of 3D selfie market. And these things are getting pretty darn good. When you actually look at the quality and the resolution, they are getting to be very good, and the cost is coming down. It's still marginally expensive for the mass market. But when you look at this, the touch point with the consumer is a scan. The clever thing then is, what do you do with the scan data? And that really puts you right back over into the domain of manufacturers making products where consumers have really very little engagement in this whole process. These guys we've been working with since the beginning of the year, and they are super good fun. This is a guy called Joe Wee, who Joe doesn't sleep. He does actually look a lot older than that now. It's a pretty old photo, and that was only in July. So Joe and Chris, his partner, are from the computer gaming industry. They're not from manufacturing or engineering. They're from gaming. Oh my God, are they from gaming? They were behind Angry Birds and Cut the Rope and all these mass platform games, all these games that sold tens of millions of copies. And they did very well, and they built a platform with hundreds of millions of users and hundreds of millions of dollars of revenue. And they sold it to EA Games, and they were tied in. And then earlier this year, they said, do you know what? We want to take the same concept and apply it to 3D printing. Mass market. But not where the 3D printed thing is necessarily the value you're buying. it's what it allows you to do. So let me explain. So these guys, they launched 2 weeks ago. The first product line is these. So those are the 3D printed objects. So they licensed to Aardman. The thing about Joe and Chris is they're door openers. Within 2 months, they'd already signed up, I think, Universal, is it PMI, the big licensing branding agency, Warner Brothers, Aardman, Disney, Pixar, to the concept. And it's a great concept. The concept is you chip everything. So when you print it, you chip it. You put near-field RFID into every object. And you do that so that you can add a value proposition. So you don't buy a 3D printed Wallace & Gromit. What you do is you buy a 3D printed low-value exclusive Wallace & Gromit signed by Aardman with a chip in it. And the chip then lets you open up a whole series of unreleased movie footage from Aardman that no one else can get to unless you've got the 3D object. You could do it with injection molding, but the exclusivity isn't there. The opportunity to respond to market trends isn't there. So this responds to the market trend by being able to manufacture on demand. This has got some really interesting permutations now in the music industry. So the music industry's on its knees. Okay, what about embedding access to music into objects? What about embedding access to film into objects? You know, why does digitization of creative industries, music and film, have to be the death knell of tangible objects? What about making tangible objects lead you back into a digital domain? Now, at the moment, you have to embed an RFID chip. You have to put it in. We're not that far away from printing near-field RFID. Give it 5 years, we'll print it into the object, or we'll use some other terahertz scanning-based way of embedding intelligence. So, again, this is right back in that domain of making products, but it's making high-value, tangible products that have got some kind of unique USP. So that's our ecosystem. Those are the things that are going on, and I think it is an ecosystem. They do all relink together. They're all reliant on one another. How big is it? It's always difficult to value this, and there's lots of double counting goes on here. So, you know, there's a fantastic report that Waller's Associates publishes. You know, if you look at the numbers, industrial materials market was about $570 million last year. The machines market was about $970 million. The industrial services market is supposed to be $1.5 billion. Unfortunately, that includes some of the aspects of the hardware and materials, a bit of double counting there. The consumer materials market last year was about $30 million. So it's nowhere near the scale that the industrial market is. The hardware market was about $100 million last year. So again, nowhere near the scale. What's interesting, though, is the growth. If you look at the industrial additive manufacturing sector, it's growing at about 29% year on year. The consumer 3D printing side of my ecosystem is growing at 100 to 10%. They actually converge by 2020. One is as big as the other, assuming they continue to grow at those rates. But, of course, that's only a small part of the ecosystem. What about all the blue water in between? All about the other ideas, linking manufacturing capacity to consumer. There's a huge amount of value in there. You know, we haven't put a market value to that yet, because it's very, very difficult to understand the true size and scale of that. But, and this is the big but to that kind of, oh, it's going to be a $20 billion market and everything will converge. If it does converge, the revenue streams all start to shift. So, what do we mean by that? Convergence. Take a look at technologies. You know, 3D Systems, who have a stand out there, I don't know if they have any SLA on that stand, make a machine, or recently may have stopped making the SI2, stereothography machine, $250,000. When you look at it, when you get under the surface of it and look at its capabilities of what it can do, it's not that dissimilar to a Formlabs Form 1. Yes, the build envelope is a bit bigger. Yes, there are more materials available to it, but that's a materials issue, not a technology issue. But the Formlabs machine is almost 1/100th of the price. So that's an interesting conundrum. Stratasys, so FDM. Yes, we know there's lots of low-end FDM machines. There's actually also some high-end FDM machines that are bigger and cheaper. So, you know, if you look at the MC400s, 150K, the latest big rep machine from Germany is actually twice the volume inside. Thermally controlled, larger build envelope, for under half the price. So what's the point of this? Well, the point is the technology is shifting, and that's changing the value of the industry. because the industry was based on selling machines at 150,000, 100,000, 50,000. It's shifting towards an industry of machines at 30,000, 40,000. So even if our growth projections carry on the way they're going, the cost of machines is coming down, the monetary value won't be as large, which then makes you think, well, actually, therefore, the opportunity space in the things that you use the technology for is bigger than just making the machines. This is a really interesting one, I think. Roland, no disrespect to any of the companies we've worked with over the years, but that's a proper company, isn't it? Roland. It's been around for 40 years. They make everything from, I had a Roland Juno synthesizer when I was a kid. They make electronics products to very, very high quality to the nth degree. And now they're selling sub $5,000 DLP-based systems, competing against $80,000 systems, 16-fold reduction in price. That's the way the industry is maturing. On the consumer side, it's maturing as well. It's maturing even further. And I think this could be as big a tipping point for 3D printing as the original RepRap project. So this was something on Kickstarter earlier in the year, the Micro 3D. $349 for a 3D printer. Plugs into your USB port. It's powered from USB. It's injection molded. I guess it's probably made in China en masse. And with some engineering, when you look at it, you could probably get the bill of materials down to less than $60. Yeah? It's going to have a retail price that's below an Xbox. So this is going to be a really, really interesting litmus paper for how interested people really are in consumer 3D printing. Because until now, all the naysayers and skeptics have said, oh, but it's too expensive for the consumer. No, it's not. It's cheaper than an Xbox. So actually, I don't think price will be the thing that will stop adoption. I think the key will be, is there actually anything to print? Where's the useful stuff? How does it improve my life, whether that's through recreation or education or whatever my hobbies are? So the smart money's not in making the machines anymore, it's about making the things that the machines make. It's back to data. The other thing that we're seeing, which again changes this whole economic argument for industry growth, is around capability. If you take MakerBot just as an example, that's been an interesting trajectory, and I think, is Jenny speaking tomorrow? Yeah, so Jenny Lawton from MakerBot, CEO at MakerBot, speaking about this tomorrow, I guess. But they went from taking an open source concept designed by many to an open source machine that they sold as a kit to an open source-ish machine that they sold as a kit, or they'd make it for you and assemble it, to a machine that you couldn't buy as a kit that was closed source, still looked like a tea chest, still made of plywood, to a fully functioning machine, to an acquisition by a company that actually has all the intellectual property, to a machine that's highly capable, closed bed, thermally controlled, and actually has the accuracy and resolution of the machines that it's now displacing. Yeah, that's capability growth. And we're seeing that across all these technology platforms, whether it's DLP or SLA. That will continue. So you couple that with the reduction in price, that's really, really quite a change in the industry. The other thing that we're seeing, and this to me is really, really important, is this convergence of 3D printing technology and the Internet of Things. So if you're not familiar with the Internet of Things or the Internet of Everything, the concept of IoT is the concept that pretty much all valued electrical devices in the future, not necessarily even electrical, it could be sensing and monitoring, devices that are important to you will be web-enabled. They'll be intelligent and they'll communicate. So yes, your fridge, you can scan your milk bottle and it will tell you when it's full and it will populate your shopping list and all this sort of nonsense. But actually in manufacturing it's really important. IoT is really important because it's about connectivity. Now, at the moment, when you look at 3D printers, the consumer 3D printers are technologically more advanced than the industrial 3D printers. So if you go out on the MakerBot stand out there and have a look at their Generation 5 machines, they've got some really interesting IoT elements. Built-in cameras that stream data live to the internet so you can monitor what's going on. Performance monitoring heads that monitor the amount of material that you're consuming. They do real-time monitoring. They'll stop, they'll tell you what percentage of the build is left to print. They'll send it to your iPhone. I don't think you get a picture of Brie with it. I think that's additional. But what does it tell you? It tells you really interesting things like, hey, I've started a build, and actually there's 14 hours of build left. and it's 6:10 and you only just left the office and I've run out of material, do you want to come back? Or it tells you there's only 3 minutes of build left, finish it in the morning. So intelligent things. What becomes even more interesting is when you take those sorts of technologies and then you start coupling it with some of the other things that are happening in the additive world. So this kind of harps back to some of the things we've been doing with the Intellectual Property Office. Our good friends at Gartner believe that by 2015, which I think is 2 years away, or even a year away, $100 billion a year of intellectual property value will be lost because of 3D printing counterfeiting. I think that's a bit over the top, but it's an interesting concept. If I can access data for 3D printing, then it'll just be like the days of BitTorrents. I'll just go and look for music and download it surreptitiously, or I'll go look for films and download them. I'll go looking for files. And actually that isn't how people think anymore, because as I said earlier, iTunes works, it's really easy. You know, it's £3 for that album and it appears on my phone and my iPad and my laptop and it's all around me. The intelligence is in how we get the data. And what we then have is the idea of protecting things. So, you know, I can pay £9.99 a month to Spotify and get any music in the world I want, when I want it. I can go to Netflix, pay them whatever, £5 a month, and get access to millions and millions of different films. So why do I need to download them? So this is an interesting model. It didn't exist going back, I suppose, what, 10 years ago, 15 years ago, when piracy was at its height. You know, the height of music piracy existed because we didn't have broadband. We have broadband now. We can stream things in real time. We have 3G and 4G. We don't need to download things before we look at them, listen to them. We can do it all in real time. So a few smart guys like 3D Shield and Authentize have done some really interesting things where they've said, okay, if 3D printers are going to become Internet of Things devices, then why don't we stream things in real time to printers when people want things? Because you don't want the file, you want the object. And if you want the object, well, actually, why don't you just link into a stream that feeds your printer? And if it fails, that doesn't matter. It's like failing with a download. The system knows the download failed, it gives you it again. Yes, some smart bugger somewhere will find a way of copying the file, corrupting it, passing it on to their friends. But if this becomes simple enough, then all of a sudden it becomes an interesting way of realizing valuable digital assets. Then, of course, you go back to 3D hubs. Then it gets really interesting. So 7,200 3D printers around the world, all linked together on a network. Ooh, crikey, that's really interesting, isn't it? So you've got a network of 7,200 machines. You've got software architecture that lets you stream data to machines without infringing people's intellectual property. You've got machines that are intelligent enough to know whether they can or cannot print. Are they ready or not ready to print? Yeah, and then you've got brands who are saying, actually, I don't want to sit here being a maker anymore. I want to sit here being a digitizer and feeding digital data to consumers. And then you've got consumers saying, well, I don't want to make it, but the guy around the corner's got a 3D printer and he's friends with my daughter's mother's brother's dog owner. You know, years ago, we talked about additive manufacturing was about distributed manufacture, you know, this very different concept of manufacture. And actually, it's never materialized. What's happening is it is now materializing through 3D printing. You know, the 3D printing home community is leading the way for how industry could become. So, Internet of Things enabled stream data to IoT devices on massive global platforms. It's already happening. So, just to kind of summarize, we've gone through that whole kind of ecosystem. What is it? Where's the businesses? Where's the, to some degree, the blue water? Where's the red water? What's already being done? I think there's a huge amount of blue water out there. You know, we get no end of great ideas being pitched across our desk that, you know, you'd love to run with every single one, but you don't have the time and the capacity. There's lots of great ideas for products, great ideas for services, not so many great ideas for technology, because we probably don't need more technologies. We need great ways of applying the ones that we have. The hardware that we've got, I think, you know, it will evolve. It's going to get faster, it's going to get cheaper, it's going to get better. It's got to be about, you know, something new. The Me Too mentality of making machines has got to stop. There isn't capacity for that, there isn't demand for that. We need good, new, innovative technology. Software, accessible, intuitive, More and more cloud-based software as a service business models. I'm sure there's lots of opportunity space there. Streaming, digital rights management, load balancing, things like 3D hubs. Lots and lots of opportunity there. As I said, I think software and hardware will converge. In 10 years' time, we won't necessarily talk about 3D printing and additive as different types of technologies. They might still be different types of users, but the technology platforms will be similar. The one thing that will happen is that I think we'll see an increase in the value of the objects, the intelligence of the objects. I think pretty soon the world's going to get fed up of bobbleheads, 3D printed gnomes. What else have we got? If you go onto Thingiverse, I think if you look at the sections of Thingiverse, the first thing that comes up is jewelry, has the most number of objects in it, and none of them actually resemble jewelry at all. Then you've got robots, then you've got vases. Okay, so once we break the mentality that the world needs more vases, and we actually need some more intelligent objects, then we'll see some growth. I've said this for years, but I do think eventually we won't, and sorry about this, Duncan, but we won't be having additive manufacturing exhibitions and conferences anymore. You know, because we don't have typewriter conferences, we don't have word processor conferences. You know, it's just a cog, and it will just be a cog in a bigger system. It's not an industrial revolution at all. It's an evolution of the way we make things. And the biggest transition isn't the hardware bit. The biggest transition is how it changes the way businesses can operate. The clever money is in re-engineering your business. Look at how you make money out of changing the business to maximize the flexibility of the technology, not the tech. And because I am an aging hippie, but I do have more hair than he does, I think this is probably, just to finish on, go home and just say this to yourself in the car, because it's absolutely true. The only constant that any of us can be sure of is an accelerating rate of change. And I think if you go out there and walk around, compare and contrast to last year, the rate of change is accelerating, accelerating, accelerating. And that's why we're enthusiastic again about 3D printing. When I came here last year, I think we said it was all nonsense and rubbish. And now we're very enthusiastic again. Thank you.